Okay, let's look at the last problem on 1G, so 3C. The root function, or the parent function, is absolute value of x. So some common points we could plug in: negative 2, 2, negative 1, 1, 0, 0, 1, 1, and 2, 2. So then what we're going to do is we're going to apply the transformation that gets it to absolute value of x over 3. Now when we do that, this is the same thing as a horizontal stretch by a factor of 3. Whoa. Sorry, that's hard to read, but you'll deal. So if I'm stretching out everything by 3, my x values here are all going to get multiplied by 3. So negative 2 gets stretched out to where it's negative 6 now. My negative 1 gets stretched out to negative 3. 0 stays at 0. 1 turns into 3. And 2 turns into 6. If you don't believe that, well, plug those into this thing, right? When you plug in negative 6, you get negative 6 over 3, which is negative 2, and then you take the absolute value, you get 2. So you can check that with all of them. Then there's only one step left. That's to take what I just had and subtract 5 from the whole thing, which is a shift down by 5, which is the same thing as saying, whoops, same thing as saying subtract 5 from the y's. So it's going to be negative 6, negative 3, negative 3, negative 4, 0, let's see, what's that going to be, negative 5, 3, negative 4, and 6, negative 3. So now we can plot those points. Let's plot 0, 5 here. And then we've got 3, negative 4, and negative 3, negative 4. And then we've got 6, negative 3. And we've got the same thing on the other side here. And so here is that function. That's the graph of f of x. And each tick mark in this case is 1. That's negative 1, that's positive 1.